Hello, can you hear me? Hello, it's a cool intro. Thanks very much. Yeah, so today I'm going to be talking about, I'll start the slide there. Today I'm going to be talking about the power of unit testing, and in particular how unit testing can lead to cleaner code. So just a bit about myself to begin with. So my name's Iain. I've been in the front-end space for about 3 years now, and I've been working with Distilled for a couple of years now. So that's my first and only front-end role. And in particular, I was working on the Done Deal app. So for those who don't know, Done Deal is an Irish online marketplace with a focus on the cars marketplace in particular. So when I joined, it was just at the beginning of a migration project. So the previous app was an Angular monolith, and when I joined, it was being migrated to Next.js with React and TypeScript. And you can see here's some of the libraries that we're using as well. So in particular, we're going to be talking about Jest and Cypress, and then the kind of use case example I'm going to use is our place add form, and that uses React Final Form. And then we're using a lot of other libraries as well. But just a bit of background. So I've been here for 2 years, and that migration project started. We initially migrated our listings page, and then we moved on to our home page, and things were going well. And then we got to our place add page. So this is where sellers will place ads for their car, for example, to list on the website. So we started migrating it, and we quickly realized just how complex a place ad page can become. And it got to the point where we had released the feature, and at the end of it, our front end team were kind of turning around and being like, okay, we kind of need to clean this up again almost. It had just become very unyieldy and kind of complex. We delivered the feature, but the code became very hard to follow. Our logic became very hard to find in the place ad, kind of that code of that page. Changes became very hard to make. So we delivered the page, but then obviously product wanted to then improve on the page, and we're kind of thinking we don't really want to touch this because it's already complicated enough as it is. And then this last point, testing time became unsustainable. So up until that point, we'd only migrated a couple of pages, and our pipelines were pretty fast. So it's pretty easy for us to push out changes and release bug fixes. But after that point, our pipelines kind of took a turn, and we were getting, I should mention, we were relying entirely on Cypress at this point for kind of all of the tests for our place ad. And it had shot up to about 15 to 30 minutes for tests, and they were running on every commit to a PR, and also running on our master branch whenever we were merging. So it just kind of slowed down our whole flow. We kind of had these two issues of the code becoming very complex for this page, and also our pipelines and testing just taking too long. So we were kind of thinking, okay, initially we were thinking, how do we kind of fix this issue with the testing so it doesn't take so long? How can we move away from a test that takes too long so we can kind of move forward? We started kind of thinking of this, why even test our application in the first place? Obviously, everyone wants to avoid bugs in your code. Then this idea of confidence in your code is kind of like a theme of this talk. The last point then is building scalable applications. So I suppose if you're building a personal project, you probably get away without writing too many tests. But when it comes to an online marketplace, and there's a multi-year migration project, you really do need tests in order to keep things in check, essentially. And there's just so much complex logic. This kind of going into this idea of code confidence. So what is that? So it's understanding your code and knowing how it's to be used. Any effects that it may cause. So in particular, React, we're thinking of side effects. So your state management and functions or hooks that are affecting your state, essentially, you want to be aware of that. Compiling your code, you want to be able to easily update or add functionality after you've delivered a feature. And ultimately, you want to feel confident when you're releasing to production. So that's a big thing there, where you don't want to be releasing a bug fix and being afraid that you're going to have a knock-on effect somewhere else. So that's that idea. So code confidence is for developers. So this is really, if you're thinking of user confidence in your app, but as developers, we really want to be confident in the code instead, or first, I should say. So that's kind of the why we should test. So now we're looking at, okay, what kind of test options are available to us as developers. So in Dundee and Distilled, we really will be talking about on the front end, we kind of break it into unit test, integration test, and end-to-end test. You can see this image on the right here is kind of the same thing, inverted, but it's kind of telling us a few things. So the first thing it's telling us is that really the volume of your tests actually should be unitary tests. So for our place ad page, the way we built it, we kind of had to rely on UI tests for everything. Whereas this is telling us, no, we should be using unit tests for the bulk of our testing. And you should definitely need UI tests and high-level tests, but they should be the minority of your tests. And the reason why, so you can see the 2 arrows here on the left, as you start adding UI tests or moving towards UI tests, you're increasing the time it takes for those tests to run, which is what we were experiencing with our pipelines, kind of slowing down dramatically. And then also UI tests are expensive. So again, it's something like Cypress is running your tests in the browser. So it's basically spinning it all up, and it's just much more expensive, resource intensive, which leads to expense. So yeah, it's going to go through the 3 different categories there. So end-to-end tests aim to test the application through its user interface. So the goal is to mimic user behaviors and test particular user flows throughout the application. So yeah, you're really thinking of a user flow when you're thinking of end-to-end test. So just to go through end-to-end tests, the pros and cons. So they're great for identifying bugs in a user flow. So they really are useful in that way. You might change a bit of logic and actually don't realize that that's kicked off somewhere and there's a use case and the page is being brought down. Cypress is going to catch that if you have a test in place for it, which is really useful. Yeah, and in that same way, it's great as a safety check or a second line of defense, really. But in terms of cons, it's not really great for developers trying to debug issues. So it's very good at catching bugs, but it's not good at telling you as a developer, okay, what is causing this bug? And it's really this idea that your UI tests are, it's just so many variables at play that you don't know. Is it an input that's changed, or is it some logic somewhere, or is it the Cypress runner itself, or is it a API call in the background from tracking that's breaking it? Yeah, and in the same vein, then it's not great for developers wanting confidence in their code. So it's very good as a safety check, but it's not necessarily making you feel like your code does exactly what you want. It's just going to catch bugs. Yeah, and then they're relatively slower, and results are subject to non-determinism. So yeah, we use the term flaky. It's basically, it would happen to us a lot, or not a lot, but it would happen time to time where we would run tests, we commit a change, and the pipelines would kick off, and our integration, our Cypress test would fail, and you'd go in and check the logs, and okay, you find the test is failing, so you run it locally and it passes, and then you might run it 20 times in a row, and it only fails 3 of the times. So it's definitely a case where possibly the way we're writing the tests, we could have improved on them. But I think it's ultimately the case where the more volume of UI tests you have, you're ultimately going to run into this issue just because of how complex UI tests are and how much variables there are at play. This image here is just, that's us as developers, and we're looking for bugs using UI tests for context. So yeah, just to jump from that then to unit and integration tests. So unit tests aim to test a piece or grouping of contained functionality in its totality. So the logic of that function must be self-contained, so there's no reliance on any external dependencies. So it really is a scoped block functionality that has arguments going in, inputs and outputs essentially, and you're testing that for a given input, you expect an output. And an integration test is kind of the same thing, except for there is a dependency. So I'm thinking of you're importing an external functionality and using it in your function. So when you're doing that, you have an external dependency. So in your test, you ideally want to mock that external dependency and then test that external dependency in isolation. So yeah, it's the same thing, the pros and cons for unit and integration tests. So they're much faster. Anyone who's used Jest will know that tests run very fast. They're isolated and repeatable. So again, that idea of non-determinism, if you run your Jest tests and they pass, you should expect them to keep passing. And if they're failing, it should keep failing. You're not going to get that same issue where they pass and fail sometimes. Easy to debug. So this is kind of, it's not so much that if you have a bug, it's not so much that the description in a unit test is clearer. It's just that the scope of code that you're testing is much smaller. So when you're trying to debug what went wrong, you're just looking in the function that you're testing. Whereas again, if you're testing a UI level, there's a lot of different things that could be wrong. So you don't really know where exactly to look. It's just telling you it expected something, and it's not like that, but it could be anywhere. Yeah, and then so you're kind of close. You're testing close to the metal, so you're maximizing code confidence for developers. So there's another cool point is it provides free documentation. So I suppose this is a way with testing in a lot of ways that you obviously have, if you have comprehensive test descriptions and you have, let's say, a feature change coming in, you might update your logic and then your test fails. So you have to update your test to reflect the logic, and then you update your test description, and you're essentially getting free documentation. And so you don't need an external like docs folder where you have to maintain that. Like a developer should be able to go in ideally and look at the test suite and understand what the code is doing from that point. Easier said than done though. And then, yeah, this idea of enforcing a modular approach to development. So this is kind of a key learning that we got from this kind of approach that we tried to refactor, is that the way we initially built our page, so we wanted to move away from Cypress tests and lean more on unit tests for our place ad page. And we realized that we couldn't, because we hadn't built our page with any particular structure that allowed for it. So we didn't build it in a modular way. So we realized in order to create unit tests, or to have the bulk of our tests as unit tests and integration tests, we would need to refactor our code to be more modular. And then when you do that, you have much cleaner code. So it's much easier to go back in and change it. So that's kind of the key learning from this. Just a con can be that it's slower to implement, definitely initially, and something that I think I struggled with myself is the mocking and just trying to, in certain cases, it can be quite complex to mock a particular library. But it tends to be, once you kind of figure it out, then it's just kind of rinse and repeat after that point. So initially it can be quite tough, but then moving forward, it's not so bad. So jump onto this slide. So we got to that point and we're thinking, okay, we want to refactor our place ad page in a more modular way. So I created this schematic here, and this schematic looks kind of scary, but it's not too bad. It's just all the panels on our place ad page, and you can see the arrows between different panels, and they're just telling you the dependencies between them. So if I look at this example here, this publish filter panel, it depends on the subsection field from this panel. So if you're a user and you're placing an ad, let's say a cars ad, you want to place that in the cars section. So if they choose the cars section, we have to update the filters, for example, like a car reg filter. But if they change that subsection to place instead of shoe ad, like we have to change the filters for a shoe filter. So these are all the dependencies. So you can see just how complicated the page is when you look at it in this way, but also that you can actually build it in a modular way. You can just also see that we also have a draft ad. So it's, if the user decides to continue on from where they left off, we have to update all the fields. And some of those fields have knock-on effects of dependencies. And then blurring any of those fields, we have to update the draft ad. So it's definitely a very complicated page. So I just wanted to show, I suppose, a bit of a demo of the kind of before and this after approach of moving more towards unit testing and having that modular approach to code. So to do that, instead of showing you that kind of complex page, I have an example form instead. So just imagine that we have 3 panels, and each panel has 2 fields. So we have first name, last name, phone number, email, and currency and price. And we're going to create some crazy requirements. So on blur of first name, if the first name field isn't empty, we reset all the fields in panel B and C. If the last name field equals FE Connect, if the currency is euro, we want to change it to US dollars. And then blurring any fields in panel B should reset panel C. You don't need to memorize these off. Just kind of focus on this middle one here. So if you change the last name to this and the currency is euro, we're going to update it. So I have a demo here then. I'm going to show you this. So I have this app running in Netlify, and I have 2 forms here. So form A is kind of our initial approach to how we did our place ad, and form B is that kind of refactored approach. When I click into form A here, you can see we have our 3 panels, and each panel has 2 fields. So we're using React Final Form, and that has a form spy component, which allows us to subscribe to the state of the form. essentially all the values of the form. So you can see here, if I, for example, change the currency to euros and I change the last name to FE Connect, you should expect this currency to change to US dollars. So we've met a requirement there that when you change this, it updates the currency. So you can see here also I have a render count beside each of the inputs. So these are the components. And you can see as I change any field, it's updating every single panel. So again, it's all kind of tied together. We didn't build our code in a modular way, so we couldn't unit test it. And we essentially had to subscribe to values in different places that led to bad re-rendering practices, I suppose, that we ended up having to pass the entire form values around, and it caused the entire form to re-render. So if I go back and I go to the kind of finished product of this refactored approach, you can see here, this is the form B. So it's the exact same thing. If I change the currency here, you can see now only this field is updating. And then if I change this again, to show that it's working the same way, you can see we updated the currency there. So it's working the same way, but the values now, so we're only scoping the re-rendering to that specific input. And it's obviously not that unit testing is causing that. It's just that when we went to try and move towards unit testing, we realized we need to refactor our code to be more modular. And in doing that, it made it much easier to control the rendering of different components. Obviously, the library manages a lot of state for us, so that made it a lot easier for us, but we were kind of leaning on that. So yeah, from there, I'm going to show just code, just jump into the code a bit. I'll try not to get too into the weeds here, but this is a Next.js application. So this, if you're not familiar, this is the pages folder, and this would be the home page. So we just have two links here to those different forms. So I'm going to jump into that first form here. So that's that form A component. And if this looks messy and hard to read, it's because it is. So you can see there's logic. Just this is our function, our component here, and we have logic just kind of top level here. We have some use effects. A bit of context on React final form. This is provided by the library, and this is like the state management of the context of the form. And then each input has to be wrapped with a field component. But you can see this form then has like a callback for the onSubmit and the values you want to subscribe to. It's very good. Oh, I just got a message. Someone does not see the code. Can you guys see my screen? Is it too small, is it? Might zoom in. Yeah, so just to jump through anyway, it's just to show, like, so for example, this panel A here, if we look at this, so I'm going to look at that first requirement of, oops, sorry, go into it here. So yeah, it doesn't really matter too much, but this is the JSX of that panel A that we were looking at. And you can see we have a use effect here. And we're checking, okay, if the last name is FE Connect and the currency is euro, then we want to update the currency to be USD. So that's kind of that functionality here. So you can see, again, this code is kind of all over the place. We have a use effect in here for this particular logic. We have other logic at this.
Oh, sorry. We can't see it, what you actually tell us, because we only see your presentation here and not the demo.
One sec there.
I'm sorry to interrupt.
No, good shout. How do I change that? Let me just stop sharing for one sec. Sorry about that. Can you see the code now?
Okay. Yes.
Sorry about that. Thanks for telling me that now. Cool. Yeah, so I'll just jump back through to there. So this is the kind of that initial form, essentially, the form A that we were talking about. And you can see here we have 3 panels being passed in. And if we look at just that requirement we were talking about, where you have, if you change the last name, the currency should update. So if I go into that panel here, you can see this is the JSX returning for that panel. And we have a use effect here that is, so if the last name is FE Connect and the currency is euro, then we want to change the currency to be USD. So that's that requirement met here. So the point is that this is living in this panel for no particular reason. And some of the logic for the rest of the requirements are living like in the form. So some of it is living in panels. And this is kind of how we built it. We didn't structure our code in such a way that there was a kind of connection between the logic and where it was living. So if I jump instead to our form B, which is like the kind of cleaner version of it, quickly jump in here. You can see this is again that same form wrapper, and then we have our form component wrapped inside. So we were able to use hooks then from the library that's provided. And you can see here, super clean. This is the entire form. You have like our 3 panels here, and then all the logic is essentially, if you think of each panel as almost a widget, it kind of contains its own logic in it. So if we look at panel A, which we were just looking at a second ago for the first form, if we jump in, you can see in here, just minimize these, you can see that the panel A has no logic in it. So in the form A, there was logic, but here there's not. We don't have that use effect here. So why is that? And it's that idea that we want to observe the state instead. So the panel A is actually, what the requirement is that the currency should be listening to the last name field. So panel C should be observing panel A. Panel A shouldn't be causing side effects to panel C. So instead, the logic is in our panel C here. And you can see, again, this is our JSX. And we have a custom hook here, essentially, that handles all of the logic for this panel. So these are it's just getters and setters from the library, essentially. And we are subscribing to, we need the last name, and we need this change function here to update the form. So if I go into this hook, you can see here, again, draw your eyes to this use effect here. It's the exact same piece of logic. So we have our last name. We're listening to the changes to the last name, and if it's changing to FE Connect and the currency is euro, we want to update our form state for the currency to be USD. So same bit of logic, but in the first case, because it didn't live in any particular place, we had no choice but to test at a UI level, essentially. So if I go into the Cypress test, this is the Cypress test for that requirement. So what we do, we go to the form page, we sort of load the entire form, the entire page, and then we get the currency, we update it, get the last name, we update it, and then we check that the currency has updated accordingly. So you have to run again all this in the Cypress runner. Whereas if we go back to the form B, and if we look at this use effect in a hook, we're able to test this hook in isolation. So if I go into this test here for that hook, you can see this is the same test, but this is in Jest now. And we're using a super cool library here. So you have testing library React hooks. If you want to test your hooks, it's really useful. You can render the hook, and then you get a few methods off of that. So for example, you can get the result of the hook, which is just what's being returned. So I can do result.current, and then if you want to call a function, for example, to test that it's behaving correctly, you can do that. And then you can see here, so we are rendering the hook, and then we're changing our last name field to be FE Connect, and then we're re-rendering the hook, and we're expecting that we're changing the currency to be US dollars. So we're basically getting the exact same test coverage, but at a fraction of it's much faster, essentially. Yeah, so that's kind of the code of that. I have a link to the repo, so if anyone wants to dig around to it, that'd be, you can go ahead, but that's that. I'm gonna stop sharing screen so I can change the window. I use Zoom, so this is why I'm a bit lost on Google, but okay, you should be able to see that now. So yeah, so this idea then, so kind of, you can see here on the left, you have your end-to-end test essentially for the entire page, and you have kind of the full volume of your page is being tested in one go. Whereas if you look on the right, you can actually get the same coverage where testing, basically tapping into each level of your component tree, you can run tests then. So you can see here, I have a test for the input itself. So like if you change the value, you expect the onChange prop to be called with the correct value. Then this is like similar to what we were looking at there, where you're testing a hook for the form. And then if we go all the way to the top level, and this is something I kind of learned from this, is that I initially thought the Jest tests were really for like low level, simple code, but it's not really. You can test at any level in your application. So even here, if I just quickly, actually, yeah, I'll just show. I won't jump back to the code, but yeah. So here we've like a use submission hook, if you can see that, and that's handling the submission. So again, it's just a function in a hook, and we're able to test that. And in that case, you might have like an integration test. So you could be calling an API, and you might need to mock that API. So that would be an example of an integration test, but it's still going to run much faster, and you're still going to get the same coverage. So then, yeah, so another point from that is this idea of separating logic from the UI. So again, you probably saw that we had all of our logic in hooks. So you tend to see where you might have code like logic above your JSX, especially if there's hooks involved. It's super simple to just move it into a custom hook for that component. And that way it's separated from the UI, so you can test it just as like TypeScript. You don't need to worry about like actually testing the UI at that point. Yeah, and you obviously create multiple hooks if you need to, like if you want to, if it makes sense to separate the logic out. And then just another thing that we kind of realized is that you can do a lot of logic within the JSX, but it's just as simple to move that logic into a hook, into like your component hook, and then it keeps your UI very dumb, and it's very easy to test that bit of logic instead of having it in your JSX. So yeah, just on that then. So at this point, you can kind of see this is kind of like the data of our pipeline. So this is like our pipelines that would run on a commit, and you can see the different steps that are running here in different columns, and you can see the clear, like the most timely step is our integration test. So this would be our Cypress test. So they're taking 15 minutes up to 30 minutes sometimes. And you can see I'm running just our place add test locally, and you can see they're taking about 5.5 minutes. So there's a lot of time tied up. So obviously Cypress also has to build the entire application before it can run its tests. So there's just a lot of time there in this testing in comparison to Jest test. So we've kind of started this refactoring. We've one panel left to refactor, kind of doing it in between other migration work. But you can see these are all of the hooks. Essentially, we've moved all the logic into custom hooks, and we're testing all of that logic. And you can see that in running those hooks, it's taking us about 5.5 seconds. So it's like a fraction of the time, but you're getting the same coverage of your logic. So you're much more confident in your code at that point. So yeah, just a quote here: if you get a failure in a high-level test, not just do you have a bug in your functional code, you also have a missing or incorrect unit test. So it's just a good point to remember if you're going with this approach. Yeah, and then just to kind of recap. So you want to use UI tests for high-level flows really, and stick to just like the high-level user flow through a page. And unit tests should make up the majority of your tests. So you really want to assess, okay, like what volume of my tests are UI tests versus, UI unit and integration tests. Yeah, then this idea of separating logic from UI is very helpful in testing approaches, and you want to aim to keep your logic organized and isolated. So you want to be thinking of an observability pattern is really useful in kind of having like widgets that control their own state, and they just observe other state that they need to. Yeah, and then the last thing is I wrote a blog post on this. So again, if I link the slides, you can have a look at that. I'll probably give a better explanation of all this. So yeah, feel free to give that a look. It also has the demo in it and the repository as well if you want to look. And yeah, that's it for me. Thanks for listening. Yes.
Thank you, Iain. So like usual, if you have questions remotely, please put out on Slack. Otherwise, Patrick will go around for the people here in person.
I don't have to walk so much. Sorry, I'm closer. Thank you for the presentation. I have actually 2 questions in one. Mainly can be summarized on what. So what do you choose to mock, and what do you choose to test?
Yeah, it's a good question. So for mocking, it's a kind of an ongoing learning for myself. We're really using like Jest inbuilt mocking functionality. So when it comes to like external dependencies, like API calls in particular, we'd be using the spy on essentially with ingest. And then for external libraries, you can just call, you can call jest.mock, and you can pass in the path for the external library, and then you can just mock whatever functionality on that. So this would be for the unit tests. For Cypress, we actually built an entire Express app that will mock our entire, all of our API calls, which might be overkill, but it works really well. So we spin that up before we run our Cypress tests. So that's kind of running as well. So that's how we mock them. In terms of choosing what to test, that's a very good question. I mean, it's kind of it's not something I necessarily have a solution for. I think ideally they test as much as you can, and we tend to focus on what is most important to the user. So what is going to impact the user. So, for example, we're working through our payments flow at the moment, and that's obviously a very crucial feature, a critical feature. So we really want to get high test coverage there. So yeah, I don't know if that answers your question, but cheers.
Nina, do we have questions on Slack?
No question on Slack. You can.
All right. You are next, I think, huh?
Thank you for the talk. I have a question about the point in separating logic and UI. So React testing library, the key point of React testing library is to test it as close as user use it. So that's why you choose the elements by label and so on. So by separating UI from logic, you step out from this path, I guess. Or how do you solve it? So do you move this user point of view testing on the higher level, on integration tests or end-to-end tests?
Yeah, so I suppose it's more so, you obviously do want to test your UI as well. It's just that, you could do an integration testing that you're testing the entire component as is, but you can also test if there's essentially you're breaking up between your JSX and your logic. So if you can test your JSX as is, so you expect it to render. So we do have snapshot tests in our code base. So again, you can provide props to the component and you expect it to render a certain way, but the actual logic is what more so we would try to move into hooks, just so we can test that without having to worry about rendering the component, if that makes sense.
Okay, so hi, thank you for the presentation. I'm passionate about testing. I do have a follow-up question to the answer you gave to the first question, which I think was asked by Mauro. So you said you created this Express mocking service, and we've had similar approaches in the past, and keeping the mocks API. So we had the similar approach with Express, and keeping the mocks API in sync with the actual API turned out to be a nightmare. How did you solve it?
Yeah, it's a good question. Yeah, so because I suppose we're working through the migration at the moment, the APIs haven't changed so much, but that's a very good point. I suppose you're essentially trying to mock every API call. And yeah, I suppose that's a challenge, whether or not you have an Express API or whether you're just using the folder that Cypress gives you for dropping responses. If your API is changing a lot, it's definitely tough to keep your mocks in place, I suppose. Yeah, it's a tough question, to be honest. It kind of, when requirements come in where we have to change something, for example, there's a backend change and we have to change the logic. Hopefully our test should fail at that point. So we kind of, at that point, we know then we need to update the mock to reflect the updated change. So yeah, maybe that might become more of a problem as we move more through the migration, but it's a good shout, yeah.
Are there any more questions from the audience here? You don't have any questions on Slack?
Someone is already typing, but I will wait until it's finished.
Yeah, thanks for the presentation. And yeah, first of all, I fully support your approach on getting rid of too much UI or end-to-end tests and trying to write more low-level tests. But from my own experience, I know that if you're gonna abuse unit tests, so fully rely on them, you might indeed gain a lot of confidence in your code, but you might lose the confidence in your product because you're only testing small bits, but you can basically lose that the idea of how they work together. So instead, again, for me, what worked, more relying on integrational tests. So basically, I think Ken C. Dodds has a very good article about the testing trophy. So basically, yeah, write integration test and then add unit test whenever necessary. So just curious, have you thought about maybe writing more integrational tests instead of unit test?
Yeah, it's a very good point. Yeah, I take it on board. Yeah, and it's something that even with the UI tests, again, like there's been loads of times where, well, not loads of times, but there's definitely been times where we, even during this migration, we have moved towards unit tests, but then there's just something that we miss. I suppose the unit tests are a little bit dumb in a way, whereas the UI test is very, it's just if you have a unit test, like again, like things like the page crashing, it's great to have a UI test at that level. In integration tests, yeah, I suppose actually most of our moving forward, I suppose, like we're working on payments flows at the moment, and we actually would have a lot of integration tests. Yeah, it's kind of tough to have. So the way we were initially creating like unitary blocks of code was passing everything in as external dependency, as arguments to a hook. But it kind of actually becomes messy to have that in your code. So yeah, I definitely would agree with you that a lot of integration tests definitely make things a lot easier. To kind of, it's a good balance between the two places.
Okay, so on Slack, Andres is still typing. Maybe we have another question from the audience here. Okay, so Andres, no pressure. We are watching you.
Yeah,
type.
it's actually not a question, I assume.
Oh, here we
The
go.
pyramid of testing was more or less content.
You want to share this with the audience, Nina?
It's pictures. I can show my phone.
Oh, okay.
So it's more the testing pyramid.
Oh, yeah. Okay, so he's just making a point that there are different models of testing pyramids.
Is there
It's not a question exactly.
Is there
right?
one question more in the audience? So yeah, Patrick, or I would do. I would say it would be the last before we go to the coffee break.
Oh, thank you. Yeah, thanks for the talk. It's been really interesting. Yeah, and it's in a similar line to what was said before with the React testing library and the coding principle of like testing as a user and not a test user. I was wondering, had you experimented using React testing library to render the components themselves rather than using Cypress? Because then you can still have these modular unit tests, isolated, I should say, unit tests, to test the component itself and not the hooks. And the reason why I ask is because I feel it's like you're testing the implementation details at this point, right? Because you might refactor the component, you might refactor the logic, but to the user, it remains unchanged. So when you come to do these refactors, you also need to change the tests as well. So do you feel like there's a risk of maybe testing implementation details here?
Yes, it's a good point. Yeah, I suppose the kind of one of the focuses we were also trying to look at as well, kind of in tangent with this is, or in parallel with this even, is to try and kind of dumb down our UI a bit, so not have as much complexity in our UI. Yeah, I do definitely take the point. We do have, so we would have tests that would be like using React testing library to actually render the component. We have our toolkit component is like our kind of base UI components, and we would be doing that there. Yeah, we really should look into that. I suppose what would be the difference between just testing at a hook level, like specifically just the logic, versus actually testing the entire component with the logic in there. Yeah, interesting point. Yeah.
Thank you. Also, thank you, Iain. And I.